All right, my seventh grade advanced class, let's go ahead and get the study guide going so you'll be prepared for your test. First one says write 21 over 5 as a decimal. I told you that every fraction is really a division problem. So this is nothing more than 21 divided by 5. We know 20 or 5 goes into 21 4 times, because 4 times 5 is 20, leaving us one left over. Our decimal is here, so when we put a 0 here, we know 5 goes into 10 2 times. Our decimal has to be 4.2. Next is number 2. Write negative 0.38 as a fraction in simplest form. If I write this as a fraction, remember what I always told you, when you have a decimal and it doesn't have a line over it, you put zeros underneath. So this is 0.38. Okay, we're going to take our line, our dot, turn it into a line. We're going to put zeros underneath each number, and we're going to put a 1 in front of those zeros. Now we got to reduce. I know 38 and 100 are both divisible by 2. Remember, we're doing this because 2 over 2 is 1, and I can divide and multiply any number by 1, and it's the same number. So I'm just turning 38 over 100 into an equal fraction that still has the same value as 38 over 100. 38 divided by 2, that's going to give me 19. 100 divided by 2 is 50. And we cannot go ahead and reduce this anymore because we're dealing with an odd number and an even number here. So our answer is 19 over 50. Let's go to number 3. Write 186% as a decimal. Well, to write this as a decimal is pretty easy. We get rid of the percent sign, right? And we move our decimal over twice. That means this is equal to 1.86 as a decimal. Number 4 says write 1 over 2 as a percent. Well, if I'm going to write this as a percent, I remember again that every fraction is a division problem. This is 1 divided by 2. My decimal's here, so my decimal is already here. When I put my 0 here, I know 2 goes into 10 5 times, so this is 0.5. Now it says to write it as a percent, not a decimal. So I have to move my decimal over 2 places to turn it into a percent. That means I have to put a 0 in this spot. This is 50%. All right, we're off to number 5, solve the equation. These are one-step equations. It means it only requires one step to solve it. Over here, I have to remember, since I'm doing an equation, I'm going to do PEMDAS backwards, and that it is a SAD map. Remember, I follow PEMDAS forward on each side of my equal sign until I can't do it anymore. I can't do PEMDAS this way because I can't add a variable and a number. And there's nothing over here to do PEMDAS with, so that's why I'm doing PEMDAS backwards now. I'll do my addition and subtraction first. Well, this is adding 1, so I'm going to do the opposite of what I see. I need to do that so I can get x by itself. As we can see, when I subtract 1 from 1, I get 0, which means I get x by itself. That's the goal. But an equal sign means this is like a big scale, and these equal each other. So if I take away 1 from this side to keep it equaling each other, I have to take away 1 from this side. And 4 minus 1 is 3. And x has to equal 3. And that makes sense because 3 plus 1 equals 4. All right, let's do number 6. Once again, we're doing SADMET PEMDAS backwards, which is SADMET. I'm going to go ahead and get rid of this line because, as you can see, there is no addition and subtraction going on. We have this decimal, and I have to make a correction. So sorry. Just looking at that made me realize number 2 was a negative 0.38. This 19 over 50 is going to be a negative 19 over 50. I have to apologize for that. I'm glad that I was able to go back and catch that. I would hate teaching you the wrong way. But just looking at this negative sign here reminded me that this one was negative, and I never followed through with that. All right, let's continue on with number 6. We have negative 0.7x, okay, equals 2.1. To do this, I have to remember that I'm going to be multiplying 0.7 to x, negative 0.7 to x, that is. So the only way to get x by itself is to divide it. We're not going to be doing addition subtraction. We're we're not going to be doing subtraction and addition. We're going to be doing division and multiplication here. They're multiplying, so I do the opposite. I'm going to turn this into a fraction, and that makes me dividing. Remember, every fraction is really a division problem. I'm going to divide it by negative 0.7. Whatever I divide from one side, I have to divide from the other side. And some people are saying, Mr. Mendes, you forgot that 0 there. Does it really matter if I put a 0 here? Absolutely not. Okay, I could have this just like this. It means the same thing. The book's just like really showing you that there's nothing there in front, and there's really no need for that. 0.7 is the same thing. So now I'm dividing 2.1 by 7. I remember that a positive divided by a negative is a negative, so my answer will be negative. And this is 0.7. To start this, I have to remember to bring my decimal over, which means I'll bring this decimal over 1. And I have 21 divided by 7. Everyone knows that's 3. That gives me negative 3 as an answer. And since we divided this away, x is all by itself. My answer is negative 3. Number 7, we got a two-step equation this time. This is going to require 2 steps of Sabbath. The first one, and again, we can't do PEMDAS forward. I can't combine these, right? So I have to do the 2 steps. My first step will be addition and subtraction. I see a negative 17, so I'm going to add 17. Whatever I add to one side, I add to the other side. I have negative 3x left over. And negative 35 plus 17, well, when my signs are different, I find the difference. And I'm going to just put this positive sign away from there. I don't want anyone confusing that number. It is a positive 17 that I'm adding here. All right, so now when they're different, I'm going to take the big number minus the small number, keep the sign of the big number, which means this will be negative. I have to borrow 1 from here, which means 15 minus 7 is 8. And 2 minus 1 is 1. That gives me a negative 18. Now I'm going to divide negative 3 away so I can get x by itself. Whatever I divide from one side, I have to divide from the other. A negative divided by a negative is a positive. And 18 divided by 3 is 6. I have a positive 6 as an answer for x. Next is number 8. This time I'm going to be doing, once again, SABMEP. When I look at each side, I cannot combine x with a number that doesn't have an x, neither on this side, but that gives me multiple steps that I have to do here. The first one that I want to do is make sure I get a positive variable, all right? So I see that 8.1 is bigger than 3.6. I'm going to add 8.1 to this side, and that way I'm sure to get a positive variable. And remember, I'm combining like terms, so I'm bringing the x with it. Okay, now the 1 comes down. I'm going to take my big number minus a small number. So I've got 8.1 minus 3.6. Remember, I keep the sign of the bigger number. Because the bigger number here is positive. This will be a positive. And now I have to borrow 1 over here, right? That turns this into 11, which makes this 5. The decimal comes down, and 7 minus 3 is 4. So 4.5 is my answer here. And remember, That was not a number, that was a coefficient in front of a variable. So it's positive 4.5x. That's going to leave me with minus 17 on this side, or negative 17, I should say. Now we got two-step equation again. I got to get rid of this 1 and get the x by itself, so I'm going to subtract 1. It means I'll subtract 1 over here. That leaves me 4.5x is going to be equal to, well, 2 negatives means I'm going to, when my signs are the same, I find the sum. So it's going to be negative 18. I add those together. Now I have to see how many times 4.5 goes into 18. And I'm thinking probably 4 times. We do this because, remember, we want to get x by itself, so we're going to divide 4.5 away. Whatever I divide from one side, I divide from the other. Now I have 18, and I know it's a negative 18, divided by a positive 4.5. Well, a negative divided by a positive is a negative number, so I know my answer is negative. When I multiply 4.5 times 4, 5 times 4 is 20, so that's a 0 with a 2. 4 times 4 is 16, plus 2 makes 18. Now you might be thinking, Mr. Mendez, you forgot to bring your decimal over, and you're absolutely right. I should have brought this over here first. And then you see that I have 180 goes in this 4 times. 45 goes into 180 4 times. So my answer is negative 4. So x equals negative 4. All right. Let's go to number 9 now. Let's see, give me some room to work here. When I do this, I got to work my this negative times a negative first. So this is going to be x. Negative times a negative is a positive. This will be positive 11 is greater than or equal to negative 4. All right. Now I realize I've got to get x by itself, so I'll subtract 11, because that will get rid of the 11 on this side, which means I will subtract 11 from this side. X is by itself now, because 11 minus 11 is nothing. And then negative 4 and negative 11 make negative 15. All right. Then it does say to graph, so I am obligated to make a graph here. Let's see. My graph should look, I wish I had made this smaller now. My graph, I'm just going to put it right here. My graph should have a negative 15 at the bottom. It should be a dot because it's greater than or equal to it. And since x is greater than or equal to it, all of the numbers that are bigger than negative 15 be pointed. That's all I really need. Let's see. Number 10 is next. Number 10 says 3x is less than negative 24. I'm going to divide 3 away from x, or 3x. That's the only way to get x by itself, because 3 divided by 3 is 1. That leaves me 1x left over. My sign comes down, and whatever I divide from one side, I divide from the other. Negative divided by positive is a negative. I'm just going to shift this down a little bit. I see that I kind of, there we go. And then 24 divided by 3 is 8. So my answer should be x is smaller than negative 8. On number 11, I'm going to have to distribute my properties first, which means I'll bring that first number and multiply it to everything inside. This will give me a negative 3 over 2x. Because negative 3 over 2 times x, that means we just go ahead and make that negative 3 over 2 into the coefficient. Now we take negative 3 over 2 and multiply it to 2. Well, this is going to give me a negative 6 over 2. I know this because this will be 2 over 1, and 3 times 2 is 6, and 2 times 1 is 2. So there's my new inequality problem. And now I can go ahead and I can't combine these because they're not like terms. I've got an x over here, right? But I can combine these. These are both numbers. So what I'm going to do is change this 6 over 2, because this is really, remember, refraction is a division problem. 6 divided by 2 is 3. So this is really negative 3 over 2 x minus 3 is less than 9. Now I can combine like terms. This is easy. I don't have to put a 2 down here and find a common denominator. Remember, I'm going to get x by itself, so the first thing I need to do is take the numbers, put them all to one side over here. So the opposite of negative 3 would be positive 3. Whatever I add to one side, I add to the other side, just like an equation. And this gives me 3 over 2x is less than, it's a negative 3 over 2x, I apologize. 9 plus 3 will give me 12. Now I have to get rid of this negative 3 over 2, so I can get x by itself. That means I'll do the opposite. Since it's a fraction, I'm dividing, so the opposite of a fraction is multiplication. I'm going to multiply to the inverse, which is negative 2 over 3. And whatever I multiply to one side, I multiply to the other. I don't bring x with it because remember, when I take negative 2 times negative 3, that's going to be 6, and 3 times 2 is 6. 6 over 6 is 1. That gives me 1x. Okay, and now I've got 12 times a negative 2 over 3. This is going to be equal to, let's see, well, this is like 12 over 1. So 12 times negative 2 would give me negative 24. And then 1 times 3 would give me 3. And since I multiplied by a negative number, I have to remember to turn my inequality symbol around. So this is going to go ahead and give me negative 24 over 3. Well, really, 24 divided by 3 is 8. So this is going to be x is greater than negative 8. And I notice I forgot to do my graph over here. Let me go back and take care of that. So this is going to be less than symbol, so I would put a circle, not a dot, where a negative 8 is. And then it's all the numbers less than negative 8, so all my lines and arrows should be pointed to the left. Over here, I got x is greater than negative 8. What a coincidence. So yeah, that means I'll put a circle over here again where negative 8 is. But this time, since it's all the numbers bigger, I will go ahead and shade over here with everything headed to the right. All right, we're off to number 12. Determine whether the equation 1 over 3 times 9x minus 12 equals 4 minus 4x has one solution, no solution, or infinitely many solutions. All right, let's go ahead and break this down first. We know we have to distribute properties, so let's go ahead and multiply these numbers across. Okay. If I multiply these across, negative 1 over 3 times 9, x, well, 1 times 9 is 9, and 9 divided by 3 is 3. So this turns to 3x, negative 3x. Let's see. And then negative 1 over 3 times negative 12. A negative times a negative is a positive. 1 times 12 is 12, and 3 times 1 will be 3. 12 divided by 3 is 4, so that would be a 4. And this would be equal to 4, what we have over here, minus 4x. Now, this tells me already I know I'm going to get one solution because my coefficients are not the same. And the rule is if my coefficients aren't the same, I'm definitely going to get one solution. If they are the same, I'll either get no solution or infinitely many solutions. It all depends if my numbers are the same. If my numbers are the same, it'll be infinitely many. And if they are not, it'll be no solution. But let's go ahead and work this out anyways. I would go ahead and find positive variables. So I'm going to add 4x over here, which means I'll add 4x on this side. This gives me x because 4 minus 3 is x plus 4 equals 4. Well, I'll have to subtract 4 from this side in order to get x by itself, which means I'll subtract 4 from this side. And that leaves me with x. I'm just going to bring this down over here. X is equal to 0 because 4 minus 4 is 0. Now, does that mean there's no solution? Absolutely not. It means that 0 is a solution. All right. So that's my answer. X is 0. There is one solution here. All right, number 13, order 7 over 33, 0.202 and 25%, and 4 over 18 from least to greatest. Which one's from least to greatest? None of these are negative, so that doesn't help me. I could take this one. I remember that every fraction is a division problem. So this would be 7 divided by 33. I'm going to cheat here a little. And I'm going to use my calculator. Because I know since it's a division problem, this is 7 divided by 33. That gives me 0.21212. Well, that tells me it's 21 repeating. So this is equal to 0.21 repeating. All right, next we have this as a decimal already. So this one is equal to 0.202. And it doesn't say repeating. So that means it's just 0.202. Next, we have 25%. Remember, 25%, the decimal can be found by moving, the decimal form can be found by moving the decimal over twice. This turns to 0.25. Everyone sees all we do is get rid of the percent sign and move it 2 times over and put that percent in front. The last one's 4 over 18. And again, I can use my trusty calculator and put 4 divided by 18. That gives me 0.2 repeating. All right, let's see which one's the smallest. Well, this is 2 repeating, and 2 is bigger than 0.21, so that's pretty big. This is 0.25, that's going to be bigger than 0.22. That looks like the biggest one. This is the smallest because 2,1 is bigger than 2,0. So from least to greatest, I would say I've got, well, the least one here is up here, 0.202. That's the first one. The second one is going to be 21 repeating. So that's going to be 7 over 33. You notice I had to take all these and put them to decimal form, and that way I could see very easily which one's bigger. This would be 0.2 is 222. That's bigger than 2,1, but smaller than 2,5. So this would be 4 over 18. And the last one, of course, would be 25%. All right, let's go on to number 14. You row a canoe X miles per hour down a river for 20 minutes. On the return trip, you travel 1 mile per hour slower. Uh, the return trip takes 30 minutes. How far did you ride the canoe? All right, number 14, kind of tricky. The way I would do it is you have to remember that we're talking about minutes here, and they want to know how far you rode. But they're talking about miles and miles per hour. So this kind of makes this tricky. Says you row a canoe X miles per hour down a river for 20 minutes. Okay, so you're going 20, you would think you'd write it 20x, but remember, this is in miles per hour, this is 20 minutes. So how many minutes are in an hour? You would not put 20. You would put, well, 20 minutes are 1/3, right? 1/3 of an hour. So this would be 1/3 x. I mean, if you wanted to write as a decimal, I guess 20 minutes out of an hour would be, whew, oh yeah, think about 20 minutes out of 60 minutes, right? This is going to equal 1/3. All right, so it would be 1/3 x, and this has got to be equal to, it's saying on the return trip, on this other side, the return trip, you travel 1 mile per hour slower, all right? So there's a -1 that's going to be in here, right? But it's 30 minutes, so you're going to be 30 minutes instead of, let me check this again here. 30 minutes, remember we're talking minutes in relation to hours. 30 minutes out of 60 minutes would be equal to 1/2. Okay, and if you wrote that as a decimal, I guess it would be 0.50. You wouldn't want to try 1/3 as a decimal, you're going to get 0.3 repeating. So now you get 1/2. And now you're going to have to multiply that to x minus 1, because that's the miles an hour, minus 1 mile per hour slower. So this would be our equation. I would take 1/2 x, so this can be 1/3 x. And that's going to be equal to 1/2 x, because 1/2 times x is 1/2 x. And then 1/2 times -1 would be minus 1/2. Okay, now we're looking for x, because x is going to be the miles per hour, the number of miles per hour. All right, when I do this, I'm going to have to go ahead and get my variables with a common denominator so I can combine them. I know the common denominator is going to be 6. I want to know which one's bigger, right? So this is going to be, if I multiply this to 2/2, this becomes 2/6x. And if I multiply this to 3/3, remember when I'm doing this, I'm really just multiplying this to 1, right? Because 3/3 is 1 and 2/2 is 1. So that's going to give me, this wasn't negative, so to be 3/6x minus 1/2. And now, let's see here, this is going to be bigger, so I would have to make this, I have to bring this over here, so this would be a -3/6 x minus 3/6x over here, and 2/6 minus 3/6, well, different signs, so we find the difference. Big number minus small number, 3 minus 2 is 1, so that would be a 1/6, and we keep the sign of the bigger number. -1/6x, right, is going to be equal to -1/2. Now we got to divide. We're dividing -1/6, which means we're going to multiply -6/1, the inverse, which means I'll multiply -6/1 over here. When I do this, a negative times a negative is a positive. 6 uh, times 1, and 6 times 1, that's going to equal 1. So x is by itself now. But over here, a negative times a negative is a positive. 1 times 6 is 6. 2 times 1 is 2, which means 6 divided by 2 is 3. So x equals 3. Now you might be thinking that's my answer, but no, remember, x is just the miles per hour. We need to find out our miles per hour times the amount of time that we went. We only went for 20 minutes, and that was, we represented 20 minutes with 1/3. So this is 1/3 times x. X is 3. So 1/3 times 3 would be 3 over 1. That's going to be, well, that equals 3 over 3. And 3 divided by 3 is 1. So that means over here we've got 1, right? And over here, I think we're dealing with the same thing because these equal each other, right? So we'll just work it out to make sure. We came up with, let's see, 3 over 6x, or even 1/2 x minus 2. I guess if I work this out, and this was 3, I'd have 1/2 times 3, and that's going to be 1.5, or 1.5, right? I'm working with fractions here. 1 and 1/2. And then, let's see, minus 1, right? Let's see here. 1 and 1/2 minus 1 would give me 1 and 1/2 times x. I'm sorry. And x is 3. Oh boy. 1/2 times 3, 1 and 1/2, the minus 1, which we said we have, well, actually, no, minus 1/2, right? Because 1/2 times -1 would be -1/2. So this would be equal to 1 again. Oh, very good. So we have 1 on each side, and 1 plus 1. Well, that equals 2, because it says how far did you ride total? So the answer would be 2 miles. Oof. That was a tough one. Let's try number 15. Number 15 says your goal is to raise more than $215 in a charity fundraiser. So remember, we want more than, or it says more, raise more than. Okay, so we need $215, more than $215. Actually, that'd be on the other side, wouldn't it? Okay. And it says you raise $3.75 for each box that you sell. So that's 3.75. We don't know how many boxes, and I'm pretty sure that's what's going to ask us. Solvent inequality represents the number of boxes. Okay, so X is boxes. All right. You also receive $35 donation. So we have $35 to add on to here. And that's our inequality right there. This has got to be greater than this. All right. So if I do this, we're trying to find x. I'm going to have to subtract 35 from both sides. This will give me 3.75x is going to be greater than, well, it's 0. And it's got to borrow 1 here. And so, see, 8, 9, 10, 11, this would be 8. That equals 180. Now I have to divide by 3.75 to get x by itself, which means I have to divide by 3.75 over here. That gives me 180 divided by 3.75. All right, let's use our trusty calculator here. 180 divided by 3.75 is going to be equal to 48. So x has to be bigger than 48. It says, write and solve an inequality that represents a number more than 48 boxes. Well, that's all of the review. Hope you get ready for this test. Looks like it's going to be mostly easy, a couple of challenging ones there. All right, and good luck. See you in class.